In this video, we're going to cover a couple of examples of resolving vectors. And what we mean by resolving vectors is if we're given a vector that's at a particular angle, we want to know how much of the vector's direction is in the vertical direction and how much of it's in the horizontal direction. In this case, we're looking at a couple of forces. And these are two of the problems that we encounter in the first set of questions in the course notes. So let's have a look at this one first of all. So the line in red marked with F equals to 10 newtons, that's our vector force in this case. And it's at a degree of an angle of 30 degrees to the horizontal. Now, helpfully for us in the question, it's marked on the vertical and horizontal components of the vector. These are the parts that add up to make our vector, the bits that are acting up and down the way and left and right. In this case, up and right are the directions. And we're asked to work out what these two quantities are, FV and FH. So we're going to use a bit of trigonometry in order to do this. So first things first, let's think about what trigonometry tells us. Well, we remember the mnemonic, the remembering trick we're meant to use, and we say it is SOHCAHTOA. I'll just write that up on the screen. SOHCAHTOA. Just to remind ourselves what this means, it means that for sine, we use opposite and hypotenuse as our sides of the triangle. For cosine, we use adjacent and hypotenuse. And for the tangent or tan, we use opposite and adjacent. And in these problems, we're going to be given the length of one of the sides, that's our 10 newtons here, and we've got to find one of the other ones. So let's start off with considering how we're going to get FH here. So if we look at our triangle, in any right-angled triangle, the right angle is going to be opposite the hypotenuse. And when we have that horizontal line meeting the vertical line, that is our right angle, which means this red line here, which is also our vector, is the hypotenuse. Now we're given an angle of 30 degrees and we determine the other two sides in relation to this angle. The other side other than the hypotenuse, which is next to our angle, is the adjacent, and the side opposite, appropriately, the angle, is known as the opposite. And so we will be in a position where we have one of these things, in this case the hypotenuse, and are wanting to find one of the two others. Now in the case of FH, FH is the adjacent. So if we go through our SOHCAHTOA and have a look here, well, we've got the hypotenuse, so we can tick off H there and there. And we're trying to find the adjacent, so we tick off the adjacent there and there. And the only part of SOHCAHTOA with two ticks is cos. So that means if we're trying to find FH, we're going to be using the rule for cos. So cos equals adjacent over hypotenuse. So let's write that down in full. So we're saying the cos of 30 degrees, because that's our angle, cos 30 degrees is equal to the adjacent, just write adjacent over the hypotenuse. That's just one of our trigonometric ratios, that's one of our rules. So in this particular question, for the angle we're working with, the adjacent is FH, what we're trying to find here. And the hypotenuse is 10, because we're told that F, our force, our vector here, is equal to the value 10. So we'll write that down as well. Now, we can use our calculator. So cos 30 doesn't have an exact value, but we'll write it to 3 decimal places, because that's certainly accurate enough. So cos 30, we put that into our calculator, it gives us 0.866 is equal to FH, divided by 10. So what we're going to do here is multiply both sides by 10, and that's going to tell us that FH is equal to 8.66. So remember a couple of things here. First of all, we're working with a force, so it's 8.66 newtons, because that's what we're given. And lastly, what direction is it acting in? Well, if our force is acting up and to the right, the horizontal part must be acting to the right. So we draw an arrow here to indicate that. Or what we can also do is just leave it as 8.66 newtons, with the understanding that forces acting to the right are positive values and forces acting to the left are negative values. As long as it's clear in your working which convention you're using, you can write either. So it would be okay for me to leave this as 8.66 newtons as long as any forces I had pointing in the opposite direction to the left had negative values. So that's how we find the value of FH. So I'll make a wee note of that on our diagram here. I'm just going to rub out this line, but because we found that, and I'm about to rub it out, we'll make a wee note of that. That's 8.66 newtons. But I'll rub this out over here just now, so we've got space to work out FV. So going back to SOHCAHTOA, in fact, let's rub out these as well, because we're working with some different information here. This time we're going to work out FV, and we're going to, because we were given our vector and this is an exact value, we're going to continue to use the hypotenuse as one of our sides. So let's tick off hypotenuse here and here, and we're trying to find the opposite. So opposites here and here. So the only one with 2 ticks is sine. Now, it would actually be possible to use the value we've just found for the horizontal to use tan or cosine, but the reason we don't do that is because we know the value for 10 is exact, or we know we've had to do a bit of rounding to get our value for the horizontal. So it wouldn't make a big difference in terms of your answer, but in terms of working from the information we're given, it's better to stick with a known fact. It also means that if we got that first part of the question wrong, then we wouldn't be relying on that for this part here, and we could get this part right independently. So based on the information of 30 degrees and the hypotenuse, trying to find the vertical line here, which is opposite to 30, it tells us sine is the trigonometric ratio we need to use. So just like before, we write it out. So sine, the SO, is equal to opposite over hypotenuse. That's so SOH. In this case, opposite is FV, which I should have said sine of 30 degrees, and hypotenuse is equal to 10. And sine 30 is actually a very nice value, and that's why we use 30 degrees quite a lot in calculations. Sine 30 is equal to exactly 0.5. Cos 60 is the same, but sine 30 is exactly equal to 0.5, which makes it nice for calculations. So it means when we rearrange, we multiply both sides of our equation by 10. So we've got, instead of FV divided by 10, we have FV, and we've got 0.5 times 10. That will give us FV equals 5 newtons. And like I said before, we could leave this as it is with understanding that upwards forces are positive, or we can also draw a little up arrow here as well, just to remind us that this force is acting up the way. And when we're keeping track of more than one vector in a question, it can become quite important to make sure that we have got all of our directions acting in the correct way. So we've worked out here, we found out that FH was equal to 8.66, and we've just found out that FV is equal to 5 newtons, and we've got the respective directions. But as we said at the beginning, since our force is acting up and to the right, the vertical component must be acting up, and the horizontal component must be acting to the right. I'm also going to include one more example. So this is a different question from the same set. So we'll just move across here and look at our next example. This is question 5 from the sheet we've been looking at. And the reason for selecting this is because this time we don't have a nice neat 30-degree angle, and we also don't have a vector that's acting up and to the right. So we can maybe look at how we would show things differently. We've got vectors acting in different directions. But nonetheless, we're still going to make use of SOHCAHTOA, so we'll write it out at the top here to keep us right, making sure we use the right bit of trig to solve our problems. Now what you'll find is in problems like this, it's always going to be sine and cosine we're using, because the nature of a vector is that it will form the hypotenuse. It doesn't mean we never use tan in this course, but for problems like this, it's sine and cosine. But instead of just making assumptions, we'll always check. Now, when you're doing your own working, you don't need to be as elaborate as I am and write sine equals opposite over hypotenuse and all of that. You can write immediately sine is equal to FV over 50, as it will be, spoiler, in this case. But it's good practice. If you're not done this for a while or you're learning it the first time, it's a good way to check. So let's start off then, since I've mentioned it, let's start off with FV. So this time, again, we know the vector must be our hypotenuse, because this is going to be our right angle where horizontal and vertical meet. So this is our hypotenuse. So we have hypotenuse, so we can tick them off straight away. And FV is opposite our 40-degree angle. So we're ticking these off again. And unsurprisingly, like I said, it's sine we need to use to find FV in this case. So I'll just skip the opposite of our hypotenuse this time. I'll write it out. So sine 40 degrees is equal to opposite, which is FV. In this case, that's the side that's opposite the 40-degree angle over the hypotenuse. And the value this time is given is 50 newtons. So let's do our calculation. Sine 40, and I'm not doing this in my head, I looked it up in advance, is equal to 0.643 equals FV over 50. And if we multiply both sides by 50, we're left with FV is equal to, again, not done this in my head either, 32.15 newtons. Now, again, we can leave this at just a positive value, or I can draw a wee arrow here to show acting up the way, to show it's acting in that direction. So I'll make a wee note over on the side. We worked out FV, it was 32.15 newtons. I'm going to rub this out just now so we can work out FH. And of course, the V and the H stand for vertical and horizontal. I should have mentioned that at the start. We'll just rub out our ticks again so we can use our SOHCAHTOA we've drawn at the top. Save myself some writing. So we found the FV, and now we want to find FH. Well, let's again look at our SOHCAHTOA. We know we've got H because the hypotenuse is the vector we've been given. And this time we can see FH is the other line that's next to the angle. And so because it's next to the angle, it's not the hypotenuse, it's the adjacent. So we can tick that off there and there. And again, we're left with two ticks for cosine. So it's cosine we're using for this side. So again, we can write cosine 40 degrees is equal to the adjacent, which this time is equal to FH, over the hypotenuse. And again, we've been given the value, it's 50. Cosine of 40, put it in your calculator, and it gives us 0.766. And multiply that by 50, and multiply FH divided by 50, and we're left with FH equal to 38.3 newtons. Now this is where the negative sign can come in, because we finally got an example of a force that's not acting right or up the way. So we could have drawn an arrow to the left, but I can just put a little negative before that, and that's telling me this force acts to the left. So I'll write it on our list here. It was minus 38.3 newtons. It would be equally correct to have stuck a wee arrow pointing to the left at the end of it. It's entirely up to you what you do, as long as you give an indication of which direction your forces are acting in. So there's another 4 problems on the sheet. It's the first set of problems you come to in the LO1 course notes, and the answers are in the book as well. So have a go, see if you can solve those, and hopefully this video was helpful.